great pleasure in introducing Mr. Dr. Pradeep Kumar Singh, former director of CIMFR Dhanbad, who is going to speak on blasting, I think controlled blasting, and he's going to tell. So it's something which will interest most of us, how to do. I think in Bombay, they use this technique for demolishing tall buildings, old tall buildings if they want. Recently they did it in Bandra. There was a hotel and that has been demolished, Okay, let's listen to...
Thank you, Chairman, and good afternoon. Yesterday I got cold in the early morning in the Darshana, so I am sorry for it that I will not be able to speak properly. But this is a work, what we did, it is a work for 7 years, because this Navi Mumbai Airport, they planned to have the Navi Mumbai Airport, but there was no land available in the periphery of that. Then they invited a committee meeting, and they decided that the Ulwe hill is having around 3,000 acres of land, and that is the only area where a greenfield airport can be constructed. It was a difficult task to construct the airport because in the hill itself, there were a number of residential people who were illegally residing in them. Illegal basalt mining was going on, but government decided that, okay, we will have a continuous monitoring of scientists and technical staff, and that way it will be constructed. So in 2016, November, we started the work. First blast was conducted there in 2016. And the timeline given by the CDCO was that all the construction work, this blasting work should be completed by 2023. And I am proudly saying that we completed all the job because they deployed 4 construction companies, and we submitted the designs, implemented it on supervision, and without any accident, without any fatal, and without any litigation, whole work was executed. So that's briefly how science and technology can be used, and explosive can be used for good work. Because in recent past, we are hearing 2 days what explosive can do. So this is the area, because there was one of the tasks was there, Ulwe Hill is also flowing in that area. It was one of the tasks that we should divert the Ulwe Hill because they wanted to have 3 runways, and each runway have more than 3 kilometers of length. So one of the major tasks was to divert the Ulwe Hill also. The proposed airport, the detail is given here. It is 35 kilometers from the existing Chhatrapati Shivaji terminal, and it will be able to cater around 50 to 60 million passengers per annum. And they also wanted to have a very big park of around 610 acres in the nearby area. And the river has been diverted to flow just behind the airport. So nicely, because on the inauguration, they invited us also. I was also there when the Honorable Prime Minister was there. It has nicely been developed, but there is a lot of scope for development because they have acquired now too much land. Around 7,200 acres of land has been acquired, and that will be, once it will be totally completed, it will be one of the best airports in Mumbai, and similarly at the Jewar in Uttar Pradesh. So just to have the output, that there will be 3 terminals, terminal number 1, 2, 3, and this area, just you see overall area, how it will looks like. There will be shopping mall, complex, there will be hotels. So area-wise, it is one of the biggest airport. So we started blasting area in package 1, package 2, package 3, and package 4. So first job was there to have the package 1 and 2. It was completed in 2019, then package 3, then package 4. So we completed it by 2023. Just I will show some of the blasting designs. So we classified the total area that how we have to move, because we can't control blasting that is expensive in all the areas. So buffer zone within 50 meters of the residential structures and important ongoing infrastructure of the project, we decided that it will be by non-destruction of explosives, that will be plasma blasting, chemical blasting. Then complete area between 50 to 100 will be the muffle blasting with a small diameter of jackhammer hole, that is 32 mm, and control blasting of 100 to 300 meters of the structures with shock tube initiation system and electronic detonators. And beyond 300 meters, all the blasts were normal blasts with an ammonium nitrate and fuel oils. We are listening in the news since last 2 months. Ammonium nitrate itself is not an explosive, sir. Just I wanted to confirm it. Ammonium nitrate is a fertilizer, but once it is mixed with fuel oil, that is diesel, in the ratio of 94% ammonium nitrate and 6% diesel oil, it becomes explosives. So only ammonium nitrate is not an explosives, but once it is carbon is given to them for the chemistry people, once you give the carbon to the ammonium nitrate, it becomes explosives, and it can do any disasters, any constructive work, whatever you want to use it, sir. So joint mapping and profiling of blasting area was done. Blast design, control blasting, and normal protection blast was conducted. And 4 of the staff, PhD students and technical students, were permanently posted, and scientists used to visit for a week in that area. I am happy to say here that 2 of our students, Ranjit Paswan and Himanshu, got PhD based on this experimental work, sir. What will be the safe explosive? So we use that our code from the other researchers, that what will be the optimum amount of energy required to give the armor rock. Because one of the concern was of the people that for the filling of the Ulwe river, we should give the armor rock size of 300 to 700 mm. God Sahib is knowing that it was a very difficult task, that each and every blast should produce minimum 60% of the rock size, fragment size, in the range of 300 to 700 meters. So joint mapping, fragmentation size mapping, everything was done. And I am happy to see here that Ulwe Hill, total Ulwe Hill was filled with this type of armor rock, and river was diverted in the peripheral area of the airport. Monitoring of ground vibration, because there is a lot of residential areas. I will show the views. Noise was also monitored for each and every blast, fly rocks, equality assessment, and safety standards. All their methodologies. The type of rock is the basalt. Volume of the hard rock was 62 million cubic meter. So length of the hill was 2.1 kilometer, and width of the hill was 1.2 kilometer in the central region, which was blasted. Height of the hill to be flattened, it was 84 meters. So we started from 84 meters and came down to the level of the river. The time period given by the authority CIDCO, that is the CIDCO, was 2023. So whatever requirement was there, we completed it. Battery is not there. Okay. So just you see the view of the hill. There were basalt mining was also, stone quarry mining was done in a hazard way. Because when we visited the site, we saw a lot of crushers without any permissions, and mining was still going on. It was a difficult task for CIDCO to stop them, but finally they convinced by their resources. And we also monitor the in-hole velocity of detonation of explosives for experimental purpose. We simulated the blast and how much fragment size is required. That is also given in that area, sir. So Ulwe Hill, just you see, in both the flank, it is flowing. And now it is the runway of 3,900 meters. So initial view I am showing you, and I also show what is the final view. This type of cliff, we faced more than 100 cliffs. It was very difficult to blast. It was lying there. But I will show some videos if time permits, and chairman allowed me to give me 2-3 minutes more. Then we also successfully demolished all the cliffs, and now this area is free from any cliffs or any unwanted rock formation. So there are a lot of vibration standards. So our institute also did it, and we have given that what should be the standard, and now we are following our standard, because more than 300 documented data, we constructed the structures in the coal mines, and we studied for 4 years, and accordingly we given the standard which was accepted by regulatory agency in India. So we followed our standard, and accordingly all the blast data were recorded, presented, because every day our staff has to give that what is the recorded data to the authority, because there was a committee was constituted who was monitoring our blast design and outcome. Initially, we optimized blast with design, whatever the data was coming from the softwares, but we experimented it, we modified it, and we also modified that how much time is required for moving of one hole from the other hole. Because most of people are not familiar with it, just you see that it is a geometry blast. So if you are initiating the blast from here, if you are not giving proper time to move from here to here and then here, that there will be ejection of fly rock. And it can go from the top to 500, 600 meters. And that will be disastrous, sir. So it was a very difficult task that how we have to give the distance between the two holes and between the two holes. So that is called burden and spacing. The hole diameter was 150 mm. Number of holes, it was 80 in a particular blast of this, and bench height like this. So all the data whichever had been modeled and based on our experience, the designs were given and implemented. Blast vibration signature was recorded. One of my colleague, Professor Datta, was saying that in earthquake, 10 hertz natural frequency can become. But we recorded the frequency in the range at 10.1 to maybe 150, 60 data, maybe here, I am not remembering exactly. But in earthquake, more or less frequency is in the range maximum in up to 2 hertz. This is the signature what we recorded due to blast vibration, due to dynamic loading. It is the only phenomena of 2 to 3 seconds, sir. So what should be the scale distance so that vibration is well controlled? This type of analysis was done by us. So I am not going to in detail. Rock fragmentation size, as I told you, it was done, and 60% of the rocks were of armor rocks in the size of 300 to 600 mm, and that was filled to a level different. Just you see. We also monitor the velocity of detonation of explosive. Just to have the view of audience, this is ammonium nitrate fuel oil, and we have given some emulsionizer. So this becomes emulsion explosives. And that emulsion explosives, what is the rate of burning, how disastrous it is, how much gigapascal energy it is detonating, it is imparting, all were recorded, sir. So this type of wave, more than 4,000, more than 5,000 of velocity of detonation of explosive was deployed there. And accordingly, analysis, I am not going to this part. I will play some video that will be of more important. V1. So the blast which were performed from the top of the hill in initial stage, because it was a very difficult task that there should not be ejection of fly rock, otherwise it will travel height and distance, it will go to the nearby surrounding areas, because people are not leaving the site. We started blasting on the instruction of NI Sidco. So after 1 year, people were little bit, after getting compensation and everything, they got shifted to other areas. Some view of blast. It is not a control blast, because if you are going to control blast, electronic detonators is costing too much. It was a general normal production blast, but expertise of our scientists and project fellows, they conducted nicely, sir. This is the Ulwe hill, now came down, and near the Ulwe hill also we blasted it, and that hill was, that's the Ulwe river. That Ulwe river was filled with the armor rock of this quarry. Only 1 minute, sir. This was a difficult. You see, the traffic is going on. It was only around 60 meters from this area. So all the traffic and this type of cliff were there, and we have to blast it because rock is very hard. So we stopped the traffic, and we did this. Congratulations. So, finally, the land development of Navi Mumbai International Airport was completed safely, following the recommendations of CSIR CIMFR. It involved 8,550 blasts and 19,665 blast vibration data were recorded and were submitted by signature of our scientists to the CITCO. And finally, it was inaugurated on 8th October 2025. Thank you very much. Now, this is the view, overall view of the international airport. And after 4 years, when all the parks and everything will come, it will be one of the best airport in Indian history. Thank you very much for your patience, sir.
Thank you very much. So we can have few questions. Yes.
The rock which you got after the blasting, how it was used and removed?
No, there was, because armor rocks generally, we got to the center of area.
Okay.
In the center of area, we did mean size, fragment size, and area-wise analysis. I could not show you.
Because when you are removing the whole hill, a lot of rock is created. So how you dispose of that? Or how it was used in the build-up of the airport?
All the maximum 60% of the rocks were for the Ulwe River, for diversion of the Ulwe River.
Okay.
60% of the rock was there. And remaining rocks, they sold it to the stone quarries.
Oh, okay.
So when this river is diverted, is there any danger of flooding?
Sir?
Is there any danger of flooding once you do the river diversion?
No, we don't face because the water in the river was only 5 to 6 meters, sir. It was not very deep. And it was spread around 300 meters in the width side. Lengthwise, it was too much. So we don't face any problem because we provided the rock and their civil engineers and everything, they were doing all the things. But we also visited there and saw how they are doing, sir.
I have a short. Yes. I've heard that people use lasers, carbon dioxide lasers for making holes in rocks and so on. Carbon dioxide lasers.
Yes. Because whatever the explosive we used, we tested it in our lab because CSR CIMFR is having this only one laboratory for testing of explosive quality and their side effects, noxious fumes and everything.
I see.
So it was tested accordingly. We gave the design to the explosive supplier, that is the Solar was the major supplier, and they manufactured it. We got tested it in all this cannon in CIMFR Dhanbad, and accordingly that explosive are used.
Thank you.